PC Expert Amateur, and we're continuing our adventure and learning about factors to consider when you're choosing a PC fan or fans. In this particular edition, I am going to talk about design, because design has a significant impact in many different ways, such as visually, as well as power consumption, as well as the quality or the speed, as well as like how strong the airflow is, how strong the pressure is, and so on and so forth. The lifespan. I mean, there's just so many variables that are based on the design. Okay, so let's start with frames. There are different kinds of frames. Then the standard kinds of frames are either going to be square frames like this, and they may have carved out the area around the frame in the middle there, or it may be a solid filled frame like this one. This is an Evermax UR Vegas, and this is a Be Quiet Silent Wings Pro 4. So those are two of the most common frame types. However, there are also fans with a frame like this one. Now, this one's pretty interesting because they've kind of simulated a ring made that looks like it's made of crystals, but it's not. It's just plastic. But you'll see fans like this where the frame is rounded, and then there are these lobes sticking off for the screws for the corners. There are a small number of fans that do not even have a complete ring or frame around them, such as the Zalman SF120, which, as you can see from here, this is the whole frame, just an X, and the screw holes are on the corners there. So it is very dependent on having a strong center, but this is a kind of rare type of frame. And there are some other variations that, can be kind of eye-catching, but you don't have to buy them. You can stick with whatever one works better. Now, for some purposes, like if you're doing a radiator, the square frames are going to be the best choice, because it's going to prevent air from escaping by flowing backwards as it's going through the radiator. This may not be a good idea. But these kinds of fans and this kind of fan are especially bad when being used on a heat sink that doesn't have closed sides. And even if it's closed on all four sides, there are these gaps where air from that level of the heatsink, whether the fins are going this way or this way, where the air will come back out this way because the pressure is forcing it to go every direction. Wherever the air can find an exit, it's going to find an exit. So these they look nice, but that is a problem. Backflow is a definite problem. Now, if depending on the way you design your build, the way you situate the fans, these can be acceptable. Like this may work fairly well on exhaust, as long as what's covering it is not particularly dense. I'm not a big fan of stuff like this. I prefer the square ones. I'm a traditionalist. No, I'm not. It's not that. It's just that in terms of functionality, it's the best choice. So, so there are other brands that have interesting looking fan frames, but again, if you're using it on an air cooler or a water cooler, you're going to want to have the traditional square frames. Now, the next part is blades. The blades of the fan play a significant role in how much air will be pushed and how hard it will be pushed, which is airflow and static pressure. And so if you are in need of a fan that's going to move a lot of air, and there's no barrier, then an airflow fan is going to be the best choice. And on the other hand, if you need a fan that's got a lot of pressure to push it through a radiator or a heat sink, then you need a static pressure fan. But there are a lot of things that go into the blades itself. For example, the size of the hub. This is a really, really big hub versus the width, or not versus, but also the width of the blades, the length of the blades, the gap between the blades, whether there are double blades or rippling or textures, how rigid the plastic is. If you have a fan that has very soft plastic, it's going to tend to, when it's turning, the faster it turns, the more the blades are going to tend to flatten and become less productive. So if you have a fan that has very flexible blades, it's not going to be a very useful addition to your computer. Whereas if the blades are stiff, like Noctua uses some kind of a crystal, plastic crystal polymer or something like that, and it's very stiff, and that's one of the reasons that Noctua's fan blades do such a good job, but also because of the shape. So you'll see some fans where it's scooped kind of like this, not a lot, but somewhat. And then if you look at this, if you look at this one, you can see they've actually got double blades. So they've got these long blades, and then there's a notch, and in that area there's a short blade, and that's to help reduce backflow and produce more air in the middle. So fan blades are design are important. And again, if you have an airflow fan, there are going to be strongly pitched fan blades, and there's going to be big gaps between them. If you have a static pressure fan, the fan blades are going to have a low pitch, so it's going to be more like this kind of a shape. Whereas if it was an airflow, it would be sticking out more, almost straight across, but there's going to be an angle and less of a scoop to it. So that is how that is done. The next one is airflow and sound control. So these design modifications attempt to direct the air and or reduce noise, and can look like protrusions, indentations, slots, or even teeth on the fan's blades and or frame. For example, the Aerocool Dead Silence, the Sharkoon Shark Blades, the Xigmatex XAF F1253, the Fractal Design Dynamics X2 GP12, Deepcool TF140S, Be Quiet Light Wings. They all have these modifications of one kind or another to the fan blades to affect the airflow or affect the pressure, affect sound, the volume. The next one is bearing types. And bearing types are very important because the bearing type is one of the main factors that will tell you how long a fan will last before it breaks down. So fans with quality bearings tend to last longer and operate more quietly. Bearing type affects price, speed, lifespan, positioning, and noise. There are many types of bearings, with rifle and sleeve bearings being of lower quality but less expensive and initially not particularly noisy. And then there's ball bearings, which tend to be more expensive, along with magnetic levitation or maglev, and liquid, all of which have several types with various degrees of quality. There are things online where you can look and learn more about all the different types of bearings. I'm not going to be showing you any images. I have no way to show you what kind of bearings are inside of these fans because I can't take them apart. Well, there are some that I could take apart, but I don't feel comfortable doing that at this time. Some bearings are more susceptible to damage by dust and or the position that they're in, which is to say, is it vertical or horizontal? So when people talk about mounting a fan and they say, is it vertical or horizontal? This is what they mean. Vertical mounting, horizontal mounting, diagonal mounting, which you'll almost never see diagonal mounting. But as a fan's bearings wear out, it tends to slow down and become noisier, and this can be impacted by design and materials quality. Some bearing types only work well in the vertical position, while others work best in the horizontal position, and a few work well in both, such as ball bearing and some of the fluid dynamic bearings and maglev tend to be the most versatile in terms of position or mounting position. A lot of factors affect the bearings, including materials in the bearings and the fan itself, stable or variable speeds, fan design, frame, mounting, heat, dust, lubrication, and so on. All that can make it last longer or make it die like that. Within the talk of the bearing types, I don't know if it was the original type, but one of the oldest types of fan bearings is the sleeve. It's inexpensive. It has a short lifespan, comparatively speaking, at about 45,000 hours. It starts out quiet, but eventually becomes quite noisy, and they will die suddenly. You can delay its death by adding a couple of drops of synthetic oil to the axle under the sticker. So you'd have to take a look, find the sticker, peel the sticker off, and in the middle there's the axle. You can drop a little bit of oil in there, like sewing machine oil or some other thin oil, and then cover it back up so that the oil won't leak back out of that hole. And that is important, that also you don't get any of the oil on the plastic where the sticker sits, because then you're going to have to clean it off, and that's a pain in the butt. And hope you got it all off, because otherwise the sticker isn't going to stick. Then the oil is going to come out even faster, because sleeve bearings do leak oil. If they're mounted vertically, they will tend to wear out much faster. And as far as a horizontal mount, it depends whether they're facing up or facing down as to how badly how quickly the oil will leak out of them. They are, however, impact resistant, dust resistant, but high friction, which means they are going to produce some heat, and that friction is going to wear out the bearings faster. The next type is called a rifle bearing, but it's actually a type of sleeve. Now, the sleeve bearing is cheap, and so is the rifle bearing. Sleeve, if you think about a gun has that spiral in it that makes the bullet spin so that it doesn't kind of wobble around in the air as it's shooting out, and makes it that spin allows it to go farther away from the gun before it drops to the ground, and it keeps it more stable, more likely to actually hit the target. So the rifle bearings have a sleeve with that rifling on them to help distribute the lubricant, and they're a little bit more expensive than sleeve bearings. They also last a little bit longer, maybe 50,000 hours, but otherwise they're quite similar. They're dust resistant, impact resistant, high friction, so there's a short lifespan and more heat. The third kind, which tend to be on the more expensive side, not necessarily very expensive, are ball bearing fans. They can be mounted in any position. They're impact sensitive, however, because of the ball bearings. They are dust resistant, and they are lower friction. Now, depending on whether it's a single or double ball bearing fan, will determine how low and how long it lasts. So if you look at a single ball bearing fan, which means it's got a single ring, and these are usually combined with like a sleeve or a rifle bearing as well, they can outlast a sleeve or a rifle, but only achieve about 60,000 hours. Unlike sleeve and rifle bearings, they don't get as loud near the end of their lifespan, and you'll typically start hearing weird noises as the bearings start wearing out. So you'll have a warning, whereas with the sleeve and rifle bearings, they abruptly die. Um, let's see. So the double ball bearing fans have two rings of these ball bearings on them, which provides extra stability. And it also means that they're not as noisy. They last longer, say 75,000 hours. Again, but still, they're also impact sensitive and dust resistant. The next kind is the hydro or liquid fans. These are modified sleeves with more lubrication, and it could even be a rifle sleeve, and they may have other technology built in. Longer lifespan than the other ones, higher price for some of them, dust sensitive for some of them, and very low friction. So of them all, these are going to produce very little heat in your machine. But most fans aren't going to produce enough heat for it to mess up your machine or anything like that. So the first type is one of the oldest. There are two variations. There's hydrostatic and hydrodynamic. So in a hydrostatic fan, they actually have a pump that maintains constant lubricant pressure. So it's sealed, which means it's not going to leak. That's good. Well, until it does leak. But it's a sealed bearing with pressure that's constant because of a pump, which ensures that the bearing is always well lubricated, making them last a long time, and they can be mounted however you need them to be mounted. The hydrodynamic fans have a lubricant, but they take time to heat up and disperse. So it's the best type to employ with a secondary type of bearing for starting and stopping. Otherwise, it's fairly similar to a hydrostatic bearing. Some will leak when placed horizontally with the fan blowing up. And that is because it's not necessarily going to be a sealed unit like the hydrostatic fans. So a couple of examples here for the fans is there's the Hydrowave, which is an improved type of hydrostatic. It has less friction, longer life, maybe 90,000 hours, but it may, it is hydrodynamic, but it may leak. It is dust sensitive, but low friction. So, it's pros and cons. But overall, it's if you're looking for something with a long life, and don't misunderstand, there are ball bearings that can last 100,000 hours. There are even sleeves and rifles that can last a fairly long time. It depends on the quality of the materials, the quality of the design, the fit, and so on and so forth. Another kind is SSO or SSO2, and that is specific to the Noctua brand. These Noctua bearings combine sleeve, fluid, and maglev for superior performance, much less noise, friction, and heat, resulting in long lifespan of up to and maybe even exceeding 300,000 hours. So they're amongst the best of the fan bearings. The third type, which is much more common and probably along with the SSO Noctua variants, is very long lasting. It's called fluid dynamic bearings, or FDB, and these can last on the lower end of quality and design, can last over 100,000 hours. They do tend to be somewhat more expensive depending on the brand. They are not dust sensitive because it's a hydrostatic sealed unit, and they have lower friction. The next kind of bearing that I'm going to discuss, and there are other bearings that are not typically used for PC fans, so I'm not talking about those. If you want to learn about bearings of all kinds, that's up to you, is magnetic levitation, or maglev, or ML. These rely primarily on magnetism to prevent the parts from rubbing, but they do usually have like some kind of a secondary bearing to help with that. So along with SSO, they're amongst the quietest and very long life, over 200,000 hours. and include like Omnicool from CUI Systems and Maglev or ML from Corsair. There is another kind of bearing. It's not really a kind of bearing, and if you see this, it doesn't mean anything at all. Some companies will market, and when I say market, I mean that they're going to say whatever they think is going to trick customers into buying their product. They will market it as a long life bearing. That has no meaning whatsoever. It could be any kind of bearing. It could be any kind of quality. So if that's all you see in the description, there's no indication of whether it's fluid or ball or sleeve or rifle or maglev, then it's probably garbage and probably not worth buying. Probably aren't long life either. Because again, it's marketing BS. So stay away from anything that's only marked with long life bearing and has no description as to what kind of bearing it really is. So we finally got done with the bearing section, and now we're on to materials. The materials for the fan blades, the materials for the bearings, the materials for the frames, the materials for the corners, the materials even for the screws or the gaskets or whatever it is you're going to use, the rubber anti vibration pads. Some of them are rubber, some of them are silicone rubber. Some of them don't have any kind of anti-vibration stuff. But what the materials are made of will affect durability and quality and so on and so forth. So you want to look for fans with durable materials like liquid crystal polymer, like I mentioned, that's what it's called for that Noctua and some of the other companies use. It's one of the best materials because it doesn't easily change shape due to speed and temperature. Frame materials include not just the frame itself, but any softer dampening materials at connection points to reduce vibration transmission to the PC. Virtually all fans used to be made from only metal, but nowadays most fans are plastic, which decreases weight and thus can increase lifespan, but makes them more prone to physical damage in transit and in your computer. I've received a few with broken blades, a disconnected hub, or frame damage. So, and this is usually because it could have been damage in transit. It could have been damage at the warehouse. It maybe somebody dropped it and then put it back on the shelf. But I bought that ComEase classical computer case, and one of the fans inside the case was the blade was partially broken, and the blades were made of very and the hub were made of very soft plastic, which makes those fans, aside from the fact that they're MolXD, very poor fans to be using in a computer. I'm not going to use them. And then finally, there are the connector and cabling types, which I have talked about separately in the previous episode on PWM versus DC and some information about MolXD. But yeah, very, very quickly, a 2-pin DC fan has a constant maximum speed, no other speeds. And then a 3-pin has a tachometer wire. That's what the 3rd pin is for. And that allows your motherboard, if it's got a 3-pin or 4-pin header, to control somewhat the speed of the fan. And then the 4-pin uses pulse width modulation. But be careful when you're buying the fans to make sure that you know what kind of connector it is. Because if you get MolXD, and it's marked as 4-pin, that's not a PWM unless you can convert it to PWM somehow, like with an adapter or by changing the plug from MolXD to the PWM standard plug. And there are also proprietary connectors. So all that has been covered separately. Go ahead and watch that video, which was posted a week ago, I believe. And that should be it for this episode, except for one final thing, and this is the silicone gaskets. Okay, so I've got some silicone gasket examples for you. This is from Frozen CPU. This is held in place by two things. Number one, if you look closely, you can see that there's a lip going around the edge there. And so as long as you've got a square frame, this will be held partially in place by the friction of that little lip. Also, of course, you can mount it such that the screws are holding it into place, or it's sandwiched between the fan and the case or heatsink or radiator, and therefore it's held in place by that as well. The second kind is just a simple one that's magnetic, and obviously you can only use this on things that are that can be attracted to a magnet. This actually has mesh on it, but you can find ones that are without the mesh to use as well. But it is a magnetic mount. Some of them will come with a metal backplate, or if you happen to have somewhere you need to mount it, and unfortunately it's a all plastic area, so then you'll have the metal frame on one side of the plastic, and you'll have the gasket on the other side, and the plastic, but you have to make sure it's not too thick, because if the magnet isn't strong enough, it's just going to fall off, right? So that is that. And then the third kind is, it's kind of a sleeve really, and this can be put over the entire fan, at least the sides of it anyways. Let me show you what I mean. So these are nice and for some fans also, but again, just like these kind of fan frames, they don't work on fans like this. But as you can see, it goes all the way around, and it can be used to help hold something in place, as well as reducing backflow, especially with a radiator or heatsink on one side. And it's got a hole going through it so you can take your cables out. This actually came with this fan. It's not particularly common, but there are places that sell that. I want to backtrack for just a second to the subject of materials. I didn't talk a lot about different kinds of materials that you'll see in fans. I mean, it's basically mostly going to be plastic. But like server fans are often made of metal. You do want to keep an eye out for what the fan is made of, because like liquid crystal polymer is very, very good, but some other kinds of plastic are too soft or too brittle. So you may get I've had a fan come to me and the blade was snapped off inside the box because it was too brittle. I think that happened with an Alpha Cool fan, but I'm not sure. Also, I would suggest that if you're not familiar with this stuff, try to go to a computer store where they actually have actual experts on this kind of thing, and ask them questions about the different materials and stuff. Look it up online. Touch the fans. Be careful, you don't want to break it. So get a salesperson to help you. But a simple way you can tell without risk is if you kind of just take your fingernail and gently do that. That's a good sign. That means that is a fairly rigid plastic. Now, I'm not saying this is the best way to find out if the plastic is strong enough, but if you can make a noise like that with very little pressure from your fingernail, then that's a good thing. If it doesn't make a nice solid noise just like that, it may not be a fan that's worth it for you. So yeah, there are some types of plastics that are very common and do well, not as well as liquid crystal polymer, but also do very well. So just keep your eyes open and look at information online to determine which plastics are going to work the best. Also try to avoid frames that are made of iron, because it's going to rust. Even if it was painted immediately, it's still going to potentially rust, and you don't want to have a frame slowly falling apart in your computer. That would kind of suck. So if you have any questions, write down below. Please like, subscribe, share my videos with everybody. I'd appreciate it so much if you could do that, so that I can build my channel, and hopefully someday I can branch out from fans into other areas like computer coolers, because at this point financially it's just not possible for me to go into coolers as much as I want to. I'm really interested in doing that. It's just can't financially. I mean, coolers, average cooler is going to be like $50, and some of them are well over $100. And then if you're talking about water cooling, you can get it even higher than that. So yeah, so if you can help me get more subscribers, that would be really, really nice of you. Thank you so much for watching, and I hope you have a great day.